Hello, hello. Hello, 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 hello. Hello, hello, hello. So we're discussing about sets. A union B is equal to A and A intersection B is A union phi is A and A intersection universal set will be A only. If I just go through the final part of this, the final part means I just go through for any two sets A and B, we just mark this. Let us say so here if I just yeah, mark like this. For any two sets A and B, we have a number of elements of A and B will be equal to number of elements of A and number of elements of B minus the intersection of the number of elements of A and B. This is a standard formula we use for finding the number of elements. In any case, number of elements of A minus B plus number of elements of A intersection B will be number of elements of A. So A minus B means this part, intersection will be this part, and obviously it will be A will be completed with that. So this symbol is symmetric. Whenever a triangle symbol is there, it's a symmetric symbol. Number of elements of A symmetric B is equal to number of elements of A minus B plus number of elements of B minus A. So that is the symmetric part. Now for any of these sets A, B, C, we have a number of elements of A union B union C will be equal to number of elements of A plus number of elements of B, number of elements of C in addition minus in brackets we can write number of elements of A intersection B, number of elements of B intersection C, number of elements of A intersection C, all of the three pairs plus number of elements of A intersection B intersection C together. That will give the data for number of elements of A union B union C. So this particular formula we generally use this one in many cases. This is an important part. This is an important formula to be used. This one is used, and of A will be summation of these two minus the subtraction of the intersection. These are the most common formulas. And A union B complement will be equal to A complement intersection of B complement. That is a De Morgan's law. Okay. And one more law, A intersection B complement will be A complement union B complement. Okay, so let us proceed further. Relations. We'll just review the last portion. So two numbers A and B listed in a specific order and enclosed in a parenthesis form an ordered pair A comma B. A is the first component, B is the second component. In general, A comma B is not equal to B comma A. A comma B is equal to C comma D, then A will be equal to C and B will be equal to D. A and B are be two non-empty sets. Now, whenever we are saying non-empty sets, then Cartesian product of A and B will be equal to A comma B such that A belongs to small a belongs to capital A and small b belongs to capital B. If A is phi and B is or B is phi, then the multiple of both of the Cartesian product of A and B will be phi. When the sets are non-empty, the case will be different. So in this case, the A and B are the two non-empty sets. In this case, the Cartesian product of A and B is defined as the product. So A comma B such that A belongs to capital A and B belongs to capital B. If A is phi, this is the first thing, and B is phi, then A into B or A, the Cartesian product will be equal to phi. Number of elements of A is P, which is given, and number of elements of B is Q, then the product of both of them, number of elements will be obviously equal to this part P and Q. So three numbers A, B, C listed in a specific order and closed in parenthesis form, an ordered triplet A, comma B, comma C, where if you just change the position, it will not be equal. That is A, comma B, comma C is not equal to BAC and CAB. Specific order, why they are not equal? Because specific order is the concept we can apply here. That's why they are not equal. Because order is specific, so that's why there is a reason behind that. Okay. For any non-component, non-empty sets A, comma B, comma C, we have A cross B cross C. For any non-empty sets A, B, C, we have A cross B cross C. Then obviously this brackets can change. A cross B cross C is denoted by A cross B cross C, or the Cartesian product of this. For any sets A, B, C, we have A cross B union C. Obviously, this will be inside element A cross B and union A cross C, A cross B intersection C, A cross B intersection A cross C, A cross B minus C. So A cross B minus A cross C. Cross B is there, and intersection of B cross C is there, obviously. So A intersection B cross B intersection A. A cross B is equal to A cross C, then B will be equal to C. A is a proper subset of B, then A cross A is a proper subset of A cross B intersection B cross A. Let A and B be two non-empty sets, and let R is a subset of A cross B, then R is a called a relation bit from A to B. A comma B belongs to R. We say that A is related to B, and we write A R B. A comma B is not belong to R. We say that A is not related to B, and we write A R R not belongs to. We just cut it out, and B domain of R A says that A comma B belongs to R. Range of R is B says that A comma B belongs to R. We define R inverse is equal to B comma A such that A comma B belongs to R. Domain of R is range of R inverse and range of R. domain of R inverse, domain of R inverse. Let A be a non-empty set, then every subset of A cross A is called a binary relation on A. Let A be a non-empty set and R be a binary relation on A. Reflexive means A comma A belongs to R or all A belongs to capital A is related to A for all A belongs to capital A. So that is reflexive in nature. Symmetric A comma B belongs to R and B comma A belongs to R for all A comma B belongs to capital A. A is related to B is related to A for all A comma A belongs to A. And transitive symmetric will be supposed transitive if A comma B belongs to R, B comma C belongs to R. It implies A comma C also belongs to R, or all A, B, C belongs to A. A is related to B, B is related to C. It implies A is related to C for all A, B, C belongs to R. A relation R on A, which is reflexive, symmetric, and transitive, is called an equivalence relation on A. We use it whenever we find whenever equivalence relation we have to prove. In that case, firstly, we have to define the relation on A should be reflexive in nature, symmetric, and transitive altogether. Then only we can prove that it is having an equivalence relation on A. So that was the basics of relations we have covered. Let us cover the function part. So if we just go with the function part, so function or mapping like x and y be two non-node sets, and let f is a subset of x uh, cross y, that is a Cartesian product, be a relation form from a x to y such that domain of f is x and no two different ordered pairs in f have the same first coordinate. F is called a function or a mapping from x to y, and we write f is such that x tends to y. So here f is called a function. So initially we've assumed that both are non-empty sets and f is a subset of this product. Domain of function f is x. No two different ordered pairs in f have the same first coordinates. F is called a function or mapping from x to y, and we write f is such that x tends to y. Domain of f, domain which is the initial value, the input value, and range of which is the output. X is such that x comma y belongs to f is equal to x. Range of f y such that x comma y belongs to f, which is a subset of y, and co-domain f is y. X comma y belongs to what we write that fx is equal to y. Y is the image of x under f, which is while x is called a pre-image of y. Two functions f and g. Y is the image of x under f, and it's called a pre-image. So that's how we treat the function part, pre-image, image. Two functions f and g having same domain x are said to be equal only when fx gx for all x belongs to capital X. Now, functional mapping, that is see for again this particular part, that is let us say there are x and y with two non-empty sets, then a rule f which associates to x belongs to capital X. A unique element fx of y is called function from x to y. We write f such that x belongs we write f is such that x tends to y. Domain of f is equal to x. Range of f is equal to fx such that x tends to x is a subset of y and codomain is y here. F is such that x tends to y is 1 to 1. If fx1 is equal to fx2 is implies that x1 is equal to x2. 1 to 1, whenever both the values are, let us say x1, x2 both are equal, it will be concluding in that case. Real function R be the set of all real numbers, then function f tends to R 10 f says that R tends to R is called a real function. Constant function, let x that k be a fixed real number, then function f says that R tends to R so that fx is equal to k for all x belongs to R is called a constant function. Domain of f is equal to capital R and range of f is equal to k. So constant function, fixed constant number, real number will be there. X belongs to R is called a constant function. Domain of f is equal to R and range of f is equal to k. Identity function, the function I is such that R is tending to R such that Ix is equal to x for all x belongs to R is called an identity function. Domain of I is range of I is equal to R. Means domain and range both are equal in that case. Modulus function, if you see the function f such that R tends to R such that fx is equal to modulus of x for all x belongs to R is called the modulus function. Domain of f is equal to R. Range of f is equal to x such that x belongs to R and x is greater than or equal to 0, or we can say in the right open, closed open, right half closed, right open bracket we are having. Right open bracket we are having in that case. We have studied this in the first one. Let me just go back here because I think this part we studied already. Let me just quickly see this. Half open, maybe we have, yeah, it is a right half open interval, right half open interval, left half open interval. That would be pronounced like this. Okay. Functions, we are just going again on functions. So in the case of modulus function, basically, in the case of modulus function, range of f is equal to x such that x belongs to R and x is greater than or equal to 0. It is right half open interval, right half open interval means close bracket 0 comma infinity in the open part it will have. It is integer function or step function. The function f is such that r tends to r, so that fx is equal to step function of x, where x denote the greatest integer less than or equal to x, where x in bracket greatest integer step function. Greatest integer less than or equal to x is called greatest integer function. Domain of f, what is the domain of f is equal to r, and range of f is z. The domain of f is r and range of f is z, or we can say the greatest integer function of 3.85. So it generally denotes this particular symbol is important to understand that it denotes the greatest integer less than or equal to x is called the greatest integer function. So 3.85 is will be 3.94 will be 0, greatest integer less than or equal to x. Generally, whatever value is increasing here, it will be lesser value. It takes so points negative of 7.35 is there. So lower value will be, you can't write negative 7 because it's a bigger value, so lower value is this one, and actually will write the smallest integer function. In this case, it will be smallest integer function. The function f is such that r tends to r, such that fx is smallest integer function denotes the smallest integer greater than or equal to x. Domain of f is r, range of f is z or z. 6.8 for the smallest integer function, it will be denotes the smallest integer function greater than or equal to x. Greater than, we can go in case of step function or greatest integer function, we go with the lower part, less than or equal to x. Here it is greater than, this way it will go for 7 here. When if f is 1, like this will go function part function. The function f is such that r tends to r, such that fx is equal to in bracket x, which whereas in bracket x, curly bracket x denotes the fractional part or decimal part of x. Note that fractional part is x minus this fractional part function of x is equal to x minus greatest integer function or step function of x. Domain of f is r, range is of f is 0, 1, range of f is 0 close bracket, comma 1 open bracket. 6.8 we are having as a fractional part function. In that case, it will be x minus that particular part, it is 6.83 minus 6, that is 0.83. It will be even here also straightforward, it will be negative of 3.65. So in this case, if I discuss, it will be negative 3.65. So it is x minus step function of x or greater function of x. So x will be negative of 3.65 minus, it will be smaller, not bigger, minus 4 That's why there's a positive 3.35 it is. Because greatest integer functions every time tells that we have to go for less than or equal to x. So less than is minus 4 in this case. So step function or greatest integer function of negative 3.65 will be smaller value, that is minus 4, and minus 4 already minus is there outside, so it will be plus 4 and negative 3.65, so obviously it is 0.35 for fractional part function of 8. Fractional part function of 8, we have x minus the, because there is no decimal here, so it will be the complete subtraction, so 0 it will come, and in case of negative 3 it will be 0 again. So this should be understood. If I just write for this or write for this one, let me write it here. It is a point negative 3.65. This can be written as 3.65 as it is minus step function, that is 3.65 of step function. It will be again minus this in this form, and it will be positive because this will become as minus 4, the smaller value, and 65 plus 4.35 is the answer here in this case. Now signum function, let us understand the signum function is a very, very important function. The function f such that r tends to r such that fx is equal to modulus of x by x, where when x is not equal to 0, or when it is 0 when x is equal to 0, it's called the signum function. Domain of f is R, and range of f is we have a range value in the bracket. It's negative 1, 0, 1. So it's called a signum function. Signum function has a property here also. Domain of the function is R and range is negative 1. Whatever we keep, negative 1 is there, 0 is there. Whenever x is not equal to 0, so let us say 2 we are taking. So 2 by 2, again 1 will become as the answer. Whatever keep every answer the same. Whenever it is 0, it will become 0 negative. So it will be negative coming, correct? Absolutely correct. So the range will be every time we have 3 elements only, negative 1, 0, and 1. Domain, even if it is R, it is called signum function. Again, let us go with this. The function f is such that R tends to R, such that fx is equal to modulus of x upon x when x is not equal to 0, and whenever it is equal to 0, the function will be 0. It's called a signum function. So obviously the domain, whatever value we take here in the real numbers, the range will be only 3 values, that is negative 1, 0, and 1. 3 elements will have every time, which is a very good conceptual part. So signum function is that. Okay. Fractional part function was also very, very uh, interesting to understand. Here we're just introducing the topics. We'll just see if anything is to be done. Okay. So we have still left with the exponential function, logarithmic, reciprocal, square root, cube root, rational function. That let us complete this one. Exponential function a be a real number such that a is greater than 0 is not equal to 1 and it is greater than 0 also. So f is such that r tends to r such that fx is equal to e to the power of x. Y is not equal to 1 because if you keep 1 there, it will be answered with 1 every time. So it is more than 1 obviously, more than not greater than 0, and real numbers will be there. For all x tends to capital R is called exponential function. Domain of f is R and range of f is 0, comma, infinity. So the value can be 0 even if because x is belonging to R, so value can be anything for x. That's why the answer can be 0 or infinity. In particular, f tends to R, f is such that R tends to R, such that fx is equal to e to the power x for all x belongs to R logarithm function. Here, f is such that R plus tends to R, such that fx is equal to log x to the base e for all x tends to R plus is called a logarithmic function. Domain of f is 0, comma, infinity and range is R. Domain is the input values will be 0, comma, infinity. Reciprocal function is f is such that R minus fractional part of 0. So fractional part function of 0 will keep here. R is such that fx is equal to 1 by x for all x tends to R minus fractional part function of 0 is called a reciprocal function. Domain of f is R minus fractional part function of 0 and range of f is R minus fractional part function of 0. Square root function, the function f is such that R plus union R plus, that is the positive values of R union fractional part function of 0 tends to R such that fx is equal to root x for all x tends to R plus union fractional part function of 0 is called a square root function. Domain of f is R plus union fractional part function of 0 and this is equal to closed interval 0, comma, infinity. It is open interval in the half right open. Range of f is half right open interval having a closed interval for 0 and infinity is open here. Cube root function f is such that R tends to R. Fx is equal to x to the power of 1 by 3 for all x belongs to R. It's called a cube root function. Domain of f is R and range of f is R. Rational function. For rational function, we know that is f is such that R tends to R, so that fx is equal to p by x upon q by x, where px and qx are polynomials and qx is not equal to 0. It's called rational function. Domain of f is R minus. Whenever 0 is there for q, obviously it will minus. So it is R minus x is such that qx is equal to 0. Operation of real numbers, if you see, f plus f and g with the real functions having domains d1 d2 respectively, then f plus g says that d1 intersection d2 belongs to implies to R such that f plus g x will be fx plus gx. F minus g such that d1 intersection d2, which are the domains, implies that R such that f minus g of x will be equal to fx minus gx, and fg such that d1 intersection d2 implies that R such that fg of x will be equal to fx into gx alpha alpha f, so that d1 implies that such that d1 is implying to R such that alpha f of x is equal to alpha into fx, and f by g such that d1 intersection d2 minus fractional part function of x is such that gx is equal to 0. implies that R says that f by g of x is equal to fx by gx, comma gx is not equal to 0. So these are the things we have completed in function chapter. Next class we will discuss about principles of mathematical induction. Okay.